All right, we are going to multiply the nerdiness in me. It's a process and it takes some time. And the nice thing about matrices is that they can be entered into software programs or just your calculator, and multiplication can become easy. But you should learn how to do it by hand because it's kind of fun and it's good brain candy. And then I'll show you how to do it on your calculator. And I think that's why matrices are so important and so popular, because they can readily be solved with an algorithm. So dimensions are extremely important when you're multiplying matrices. So quick test. What are the dimensions of this matrix? Remember, it's row by column, and columns are up and down. So this is a 3 by 2, which makes this a 2 by 4. And when you're multiplying matrices, these two have to match. So remember, it's row by column, row by column. So the column of the first matrix has to match the number of rows. The number of columns in the first matrix has to match the number of rows in the second matrix. And when you see the process, you'll understand why that works. So once you've checked that these two match, the solution matrix will be a 3 by 4. And that's really important too, because it helps you set up how basically to go about multiplying matrices. So if you know you're going to have a 3 by 4, that means I'm going to have 3 rows and I'm going to have 4 columns. And what's going to go in here, in this cell, is going to be row 1 times column 1. And it happens, its location is row 1, column 1. So the location basically tells you what to do. What location is this element? It's row 2, column 3. So how would I get the element there? How would I get the value of that element? I would go to row 2 and multiply by column 3. So understanding that these have to match, that this will be your solution matrix, and then actually setting up your solution matrix is really key to multiplying matrices. So how do we actually figure out what row 1 by column 1 is? I'm going to start over so we can have the matrices and we can see how that works. So matrix A was -4, 3, 5, -1, 0, 7. And matrix B, we're going to multiply them, was 2, 1, 0, -1, 3, 0, -2, 5. And I know I'm going to have 1, 2, 3, 4 columns. I'm going to have a 3 by 4. So how do I multiply row 1 by column 1? Well, it's -4 times 2 plus 3 times 3. Now you can understand why the number of columns in the first, remember this was a 3 by 2, and this was a 2 by 4. Now I know why the number of columns in the first has to equal the number of rows in the second, because each of these guys needs a partner. So how am I going to do the next one? You work in order. You can go down or you can go across. I'm going to go across. So this is row 1, column 2. So -4 times 1 plus 3 times 0. Are you getting the drift? Let's pick this guy right here. What goes here? Well, it's row 3 and it's column 3. So what would happen there? Row 3, column 3. So that's going to be 0 times 0 plus 7 times -2. And then you would just simplify those. This would be -8 plus 9, so that would be 1, right? If you were to say matrix A times matrix B would be, we got a 1 in the first column, and negative 4 plus 0 would be negative 4. So we need to fill in all these cells. I am not going to do them all. Hopefully you get the drift here. What was this? 0 times 0, so that was negative 14. But if you were doing it, I would suggest you do it in order. Make sure these match. This is your solution matrix. Set it up, and then basically your solution matrix then tells you how to go about performing the multiplication. Right on. No worries. What if we were given something like this? What if matrix A was 0, negative 4, 2, 5, 4, 0? And what if matrix B was 2, 8, 3, 0, negative 5, negative 2? Could I multiply those? Well, this is a 3 by 2, and this is a 3 by 2. Do these guys match? Nope. So we would say this is undefined. And why is that? Because I would multiply this row by this column, and what would happen? 0 would have a partner, negative 4 would have a partner, but then there's nothing for that guy. So that, we say that's undefined. All right. What did I want to go over next? Oh, sometimes it can seem like you might get something like this, 3, 0, negative 1. And you got to multiply that by 5, negative 2, 1. Now there's 3 things here, there's 3 things here, but think about it. This is a 1 by 3, right? And this is a 3 by 1. These match, so what's your solution matrix going to be? It's only going to be a 1 by 1. Because what are you going to do? It's a 1 by 1. So A times B in this case is row 1 times column 1. It would be 3 times 5 plus 0 times negative 2 plus negative 1 times 1. And that would be 15 minus 1. It would be 14. That would be your answer. Could be these are negatives. I don't know. We'll see an application of this shortly. Okay, the next thing I wanted to do was just look at the word problem on page 198. So I'm gonna bust that out. I know these videos are a little long, but it's what I can do for now. Oh yeah, here you go. Here's an example. One of the things about matrices, and you know, these are hokey because we're in Algebra 2, we're in high school. But here's an example of just organizing some data. We've got the women's team, we've got the men's team, hockey equipment, obviously, sticks, pucks, and uniforms. And here's how much they cost in dollars. So if I wanted to know the total cost for the women's teams, notice how that works. Sticks, pucks, and uniforms agree with sticks, pucks, and uniforms. Columns agree with rows. And that's how that works. So 14 sticks at $60 a stick, 30 pucks at $2 a puck, and 18 uniforms at $35 per uniform. And so the total cost for the women's team was $15.30. So here's an example of how matrices work. So yeah, I think that based on that, you shouldn't have any problem doing a lot of these. It looks like a lot, like, whoa, Viv, that seems to take long, but some of them are, you know, tell whether they're defined and what the dimensions would be of the product. Yeah. And then here's just order of operations, right? Negative 2 times B times C. So again, you could do negative 2 times B and then multiply by C, or you could do matrix B times matrix C and then multiply by negative 2. Multiply these two matrices, subtract the product of these two matrices. Shouldn't take you that long. And it's good practice, it's good brain candy, and it should be fun. It's fun to focus on something else. Good to go.